Alright, in this video we're looking at an introduction to graphing rational functions and some of the basics that we're going to have to do in terms of graphing these functions. This is going to be one of the most important and definitely the most time consuming, and just you have to be really on top of your game when graphing these rational functions of everything that we do here in this class. So the first thing I want to do is formally define what an asymptote is. We've talked about it a lot. Let's get a formal definition. An asymptote is just a line that the graph of a function approaches but does not cross. And I say here usually does not cross, probably because 99 times out of 100 you never cross an asymptote, but it is possible. We'll look at some of those examples later. I should also mention here this word line is very, again, 99 times out of 100 an asymptote is a line. You technically could have a quadratic asymptote or a cubic asymptote. Again, very rare. We don't look at them very often, but it is possible, so we need to mention it for sure. Okay, there are two types of asymptotes that we're mainly going to deal with, vertical asymptotes and non-vertical asymptotes. A vertical asymptote, you will never, ever cross a vertical asymptote. It's like Chuck Norris. Never cross Chuck Norris. You can't cross a vertical asymptote. The other kind, non-vertical, when dealing with asymptotes as lines, most are going to be horizontal. It is possible to have a slant asymptote. Both of these you are allowed to cross, and we'll talk about what this all means in a minute, but it is very, very unlikely that you will do so, but it is possible. So now that we have a definition of asymptotes, here's what I want you to look at. This file is up on Google Classroom as well. You're going to be using this as your guideline for graphing these functions throughout the entirety of this section. So first off, we're going to be given a function, and that function is going to be some numerator, which I'm calling n, divided by some denominator, which I'm calling d. What we're going to first look at is, well, how do we find domain? Well, domain for a fraction, you have issues with a domain when the denominator equals 0. So that's where we have our possible domain errors. X-intercepts happen when the entire function is equal to 0, meaning that y is equal to 0. So if y is equal to 0, that means that this whole fraction is equal to 0. That means the numerator must be equal to 0. Y-intercepts from Algebra 1 are when x equals 0. So literally all you have to do is plug 0 in for all x's, and you will get a y-intercept. The next things that we'll look at are our vertical and horizontal asymptotes. Actually, before we even do that, vertical and horizontal asymptotes both deal with domain. That's why they both have that little mark there, because they go hand in hand together. They both deal with a denominator equaling 0. The difference between them, vertical asymptotes happen when the denominator equals 0 and does not cancel with something in the numerator. A whole happens when something does cancel. So if you had, for example, on the top an x minus 2 and on the bottom also an x minus 2, well, you have the exact same thing. They'd cancel out. That would make it a whole. While if it was x plus 2 over x minus 2, nothing cancels there. That part would be a vertical asymptote instead. We'll look more at those examples later, but main difference is a whole cancels out, which should make sense. If you cancel that out, you've left a hole in the fraction that you have created. Now, the last part and the toughest part in this is horizontal asymptote and slant asymptote. Again, they work together, but what you need to do is you need to be able to do long division. So when you do long division, you're going to have some answer plus some remainder over our denominator. So the quotient plus a remainder over our denominator. And what happens is this horizontal asymptote and slant asymptote are what the quotient is when you do that long division. And then the only difference between them is when you do that long division, if you get just a number here for the quotient, if you get just, for example, the number 2, your horizontal asymptote would be y equals 2. If you get 2x, well, what would that line look like? It would look like a slant. That's where you get a slant asymptote rather than a horizontal asymptote. And finally, if you're crossing the horizontal asymptote or slant asymptote, that means that your function is the same as your quotient, your horizontal asymptote. That means this remainder and the whole part there has to not exist at all. It needs to be equal to 0. So the way you find where you cross a horizontal asymptote is where the remainder is equal to 0. This is a good note sheet for you to have. Make sure that you have this jotted down, and you're going to be doing a lot of this basically all week.